today, October, November 2024, paper 2, variant 3. So the first question, a sample of ethanol is left in an open beaker at room temperature. After 24 hours, no ethanol remains in the beaker. What has happened to the ethanol? So there is no ethanol remains in the beaker. That means that ethanol escaped. When any substance escaped, that means that it has evaporated. So the ethanol had evaporated as it escaped. A gas is in a sealed container with a fixed volume, which statements describe what happens to the molecules in the gas when temperature increased. So when temperature increased, particles gain more kinetic energy. They move faster. There is more collision. The frequency of the collision increase. So which statements are correct? They move more slowly? No. They collide with the walls of the container more frequently? Yes. They collide with the walls of the container with less force? No. They have greater kinetic energy? Yes. So it's 2 and 4, so the answer is D. What happens when sodium atoms combine with chlorine atoms to form sodium chloride? Sodium chloride is an ionic compound, as it contains a metal and a nonmetal. The sodium is the metal, so it loses electrons, and the chlorine is the nonmetal, so it gains these electrons. So sodium atoms each gain one electron. No, sodium is a metal, so it loses electron. It does not gain electrons. Chlorine atom loss an electron. No, chlorine is non-metal, so it gain electrons. It does not lose, so it's wrong. Sodium atoms each lost one electron. Yes, sodium is a metal and it's lost one electron as it's group 1. Chlorine atom each gain one electron. Chlorine is a non-metal, so it gains electrons, and it's in a group 7, so it gain one electron. So the answer is B. The table shows some properties of four substances. Which substances are ionic? The ionic compound have high melting point and high boiling point, as it have strong electrostatic attraction force between the oppositely charged ions, which needs high energy to overcome, and it conduct electricity when only molten to have free moving ions, but it does not conduct electricity when it's solid. So which substance is ionic? Substance 1. It has high melting point. Okay. It does not conduct when solid. Okay, that's true. It does not conduct when molten. No, that's wrong. Because ionic compounds conduct electricity when molten, as they have free moving ions when they're molten. So it's not A. It's not 1. 2. It have high melting point. Okay, that's true. It conducts electricity when solid. It does not conduct. So that's true. It conduct when molten. That's true. So that's an ionic compound. So 3. It have low melting point. Of course, 3 is not an ionic compound, as ionic compounds have high melting point. 4. It have high melting point. Okay, that's true. It conduct when it's solid. That's not true. Ionic compounds conduct only when molten. So 4 is wrong. So the answer is 2 only, so it's D. Which statement about methane is correct? Methane is an alkane. It have one carbon and it's an alkane, so its general formula is C2H2N plus 2, so it's written as CH4. It's an hydrocarbon. It contains nonmetals, so it's a covalent compound. Covalent compounds means share of electrons, and covalent compounds have low melting point and low boiling point, as there is a weak intermolecular forces between molecules which need low energy to overcome. So the covalent compounds have low melting point and low boiling point, and covalent compounds does not conduct electricity. So simply, the covalent compounds are opposite to the ionic compounds in the properties, and covalent compounds are between nonmetals, and ionic compound is between one metal and one nonmetal. So which statement is correct about methane, which is a hydrocarbon and it's a covalent compound? So in methane, positive hydrogen ions are attracted to negative carbon ions? No, that's wrong. In methane, electrons are shared between carbon atoms and hydrogen atoms? Yes, it shares electrons. It's an ionic compound. Methane has high boiling point? No, we said the ionic compounds have low boiling point because there is a weak intermolecular forces between molecules which needs low energy to overcome. Methane is a good conductor of electricity? No, we said that methane does not conduct electricity. It's opposite to the ionic compounds properties. Okay, a sample of rubidium has a relative atomic mass of 192.29. The sample contains two isotopes only. 64.50% of the sample is rubidium with a mass of 193. So, what is the other isotope in the sample? So, we want to know the mass number of the other isotope. So, first of all, we can calculate the percentage of the other isotope as we have the percentage of one of the two isotopes. So, 100 minus 64.50 equals 35.50. That's the percentage of the other isotope. So, we have the equation of the relative atomic mass, which say that the mass number of the first isotope times its percentage plus the mass number of the other isotope, which is here x, that's the unknown, times its percentage, which is 35.5, divide 100 equals the relative atomic mass, which is here 192.29. So we can make it as an equation and collect x at the unknown. So x would be 191. How? The 100 will go with the times. The 193 times 64.5 will go by minus, and the 35.50 will go by the divide, and x will be with 191. So the other isotope is rubidium 191. Okay, ammonium iron 3 citrate contains in its formula more than ammonium ion, so that's X. One iron ion, which is positive 3, as it's iron 3 here, and two citrate ions, its charge is negative 4 and it's 2, so 2 times negative 4, which is negative 8. And the ammonia, we know that the charge of the ammonia is positive 1, but we don't know how many atoms of ammonium are in this compound, so it's X. So we could calculate X by using the equation that say that the net charge of any compound equals 0. So the net charge of this compound equals 0. So X plus 3 minus 8 equals 0. So X plus 3 equals 8. X equals, so with the positive we go with the negative, so X equals 5. So we need 5 ammonium atoms to in this compound. At the charge of the ammonia is positive 1, so to reach 5 we need 5. So the formula of ammonium iron 3 citrate, it will have 5 ammonium, so B, it's the compound that have 5 ammonia, so the answer is B. Silicon IV oxide reacts with chlorine and carbon to form liquid silicon IV chloride and carbon dioxide gas. If the reaction is carried out at room temperature, which symbol equation represents this reaction? The silicon IV oxide is a joint covalent structure, so it's a solid. So A is wrong and B is wrong. Chlorine, of course, it's gas at room temperature. Carbon, of course, it's solid at room temperature. Silicon chloride, it's liquid. It's said in the question that that it forms liquid silicon IV chloride. So it's not C, as it said in C that silicon chloride is gas. So this is wrong. So it's D. Silicon chloride is liquid and carbon dioxide is a gas for sure. So the answer is D. The structure of ethene is shown. How many hydrogen atoms and how many carbon atoms are there in 1 mole? To calculate to calculate the number of atoms in 1 mole, we use the Avogadro's constant, which is 6.02 times 10 to the power of 23. So to calculate the number of atom in 1 mole, so we need to know how many atoms of carbon to know the number of carbon atoms in 1 mole. We have 2 carbons here, so 2 times the Avogadro constant is the number of atoms in 1 mole of carbon. So, and to calculate the number of moles in atoms of hydrogen, so we need to calculate the number of atoms of hydrogen, which is here 4. We have 4 hydrogen. And to see it in 1 mole, so we'll times 2 with the Avogadro's constant, which is 6.02 times 10 to the power of 23. So number of atoms in 1 mole of ethene of carbon is 2 times the Avogadro's constant, which will be 1.2 times 10 to the power of 24. And the number of atoms of hydrogen in 1 mole of ethene, it will be 4 times the Avogadro's constant, as we have 4 hydrogens here. So the answer will be 2.4 times 10 to the power of 24. So the answer will be letter A. So the answer is A. Okay, a known volume and concentration of aqueous sodium hydroxide is titrated against dilute hydrochloric acid. The volume of the hydrochloric acid needed to neutralize the sodium hydroxide is measured. 5 calculation steps are shown. What's the order of these steps to calculate the concentration of hydrochloric acid in grams per decimeter? So first of all, we have a known volume and concentration of aqueous sodium hydroxide. So we can calculate the moles of sodium hydroxide first. Then we can calculate the moles of the hydrochloric acid by ratio from the moles of the sodium hydroxide. Then we can calculate the concentration of hydrochloric acid. Then we can calculate the mass of hydrochloric acid. Then we can calculate the concentration of hydrochloric acid in grams per decimeter. So first of all, we will calculate the moles of sodium hydroxide because we have the mass, we have the volume and concentration of aqueous sodium hydroxide, not hydrochloric acid. So first of all, we will calculate the mass, the moles of sodium hydroxide. So that's the first step. Then we will calculate the moles of hydrochloric acid by ratio. So um, that's the second step. Then we can calculate the concentration of hydrochloric acid in mole per decimeter. So that's the third step. Then we will calculate the mass of the hydrochloric acid. So we can calculate its concentration in gram per decimeter. So first of all, we need to calculate the moles of the sodium hydroxide. Then we can get the moles of the hydrochloric acid by ratio. So the true order is 4 1 5 2 3. So it's C. Two different substances are electrolyzed using inert electrodes in two separate experiments. Hydrogen is produced in both experiments, which row identifies the two substances and the electrode at which hydrogen is produced. So, first of all, hydrogen is positive, so it's produced at cathode. So, of course, the answer is not A and it's not C. So, B, substance 1 is molten sodium chloride. It does not contain hydrogen ions, so hydrogen won't be produced as it's molten, so it does not contain hydrogen ions, so B is wrong, so it will be D. Substance A in D is dilute sulfuric acid, so it contains hydrogen ion. As it's dilute, it contains water, so it contains hydrogen ions. Concentrated hydrochloric acid, it's concentrated, so it contains water, so it contains hydrogen ions, so hydrogen will be produced in both substances in D, and it will be produced at the cathode as it's positive. Aqueous copper 2 sulfate can be electrolyzed using either copper electrodes or carbon electrodes. Which statement describes what happens at the positive electrode? Okay, at the positive electrode, of course, copper 2 sulfate is aqueous, so copper is positive, sulfate is negative, and it's aqueous, so it contains water, so H and OH. So H is positive as the copper, and OH is negative as sulfate. Um, the negative ion will be attracted to the positive electrode which is the anode. So the negative ion which will be attracted here is the hydroxide. As we don't have a halide, so the hydroxide will be attracted. So hydroxide forms oxygen gas. So A. Copper is deposited if the electrodes is made from carbon? No, that's wrong. Because copper is positive, so it's produced at the negative electrode, not the positive electrode. So A is wrong. Copper is deposited if the electrode is made from copper? No, that's wrong. Because copper is produced at the cathode, not anode. And he is asking what happens at the positive electrode. Oxygen gas is produced if the electrodes is made from carbon? Yes, that's true. Oxygen gas is produced if the electrodes is made from copper? No, because when the electrodes is made from copper, copper ions dissociate and form, so oxygen gas won't be produced at the positive electrode using copper electrodes. No, it's produced using carbon electrodes because if we were using copper electrodes, so copper ions will be produced too, not oxygen. So the answer is C. Which statement about hydrogen oxygen fuel cell is not correct? Hydrogen oxygen fuel cell is a cell that converts the chemical energy to electrical energy, and it makes this by producing water. So its overall equation is hydrogen plus oxygen, and it gives water, which is the only and the waste product of it. So, which statement is not correct? Chemical energy is converted into electrical energy. That's true. Hydrogen is oxidized. Yes, hydrogen gains oxygen, so it's oxidized. The reaction that takes place is endothermic. No, it's the combustion, as it's a reaction with oxygen. Any combustion reaction is exothermic, not endothermic. So that's wrong. So that's the answer. Water is the only chemical product. Yes, that's true. So the only incorrect statement is C. Which reaction pathway diagram is correctly labeled? Here, that's the energy change, that's right. That's the activation energy, that's right. That's the enthalpy change, the energy change, yes. So A is correct. If we looked at B, we will see that the enthalpy energy is wrongly labeled. That's not all the enthalpy energy. The enthalpy energy is that such this. C, it's wrong because it's opposite. The activation energy is labeled as enthalpy change, and the enthalpy change is labeled as activation energy, so it's the opposite, so that's wrong. Here, the activation energy, the arrow is pointed to the downward, so that's wrong, as activation energy is energy gain, so the arrow is upward. So the answer here is C. Which rule describes a reaction where the overall energy change is endothermic? If the reaction is thermic, the temperature of the surroundings would increase. So it's not A or B, as the temperature must increase. And the energy change should be negative. So the reaction is endothermic. So how we could calculate the energy change? By minusing the energy of bond making of by the energy of bond forming. So at C, if we made 900 minus 300, the answer would be with the positive. It would be 600. So the energy change is positive, so it's not exothermic. But at D, if we made 900 minus 1200, so the answer is negative 300. So the enthalpy change is by negative, so it's exothermic, so it's D. And that means that the energy released is greater than the energy taken in. So it's an exothermic reaction. Which process involves a physical change? Heating calcium carbonate? No, heating calcium carbonate is a chemical change, as it's changed the chemical structure of the substance. The physical changes are boiling, melting, evaporating, condensation. It's all reversible reactions, and I can return my reactant back. So heating calcium carbonate is a physical change? No, it's a chemical. It's not boiling or melting or evaporating or condensation. Burning wood? No. Melting an ice? Yes, it's melting, so it's a physical change. Mixing an acid with a base? No, it's a chemical change. In the Haber process, an equilibrium is stabilized. The forward reaction is exothermic. The forward is exothermic, so the backward is endo. Which change to the reaction conditions will move the position to the left. To the left, that means the reactant side. So the gas moles here is 4 and here is 2. So if I decrease the pressure, it will move to the left. Okay, when I decrease the pressure, it moves to the side with the more gas moles. So when I decrease the pressure, it will move to the side with the more gas moles. That's here the left hand side. Yes, so it will move backward when I decrease the pressure. As when I decrease the pressure, is move to the side with the less gas moles. So that's true. Decreasing the temperature, when I decrease the temperature, it moves to the exothermic side. So the exothermic side here is the right hand side. So if I decrease the temperature, it will move to the exothermic side, which is the right hand side. So that will not move the equilibrium to the left. So that's wrong. If I added more nitrogen gas, if I added more nitrogen gas, so I will increase the reactance. When I increase the reactance, so the equilibrium will shift to the products to reach the equilibrium again. so it will shift to the opposite side, so that's wrong. When I increase particles on one side, the equilibrium will shift to the opposite side. So here I increased in the left hand side, so when I increase in the left hand side, so the equilibrium will shift to the opposite side, which is the right hand side, so that will not increase the left hand side. Removing the iron catalyst, the catalyst does not affect the equilibrium, so that's wrong. The flow chart shows some properties of a metal oxide. The metal oxide is a component of the brass. The brass is contains zinc and copper. Okay, this metal oxide react with hydrochloric acid to form water and salt. When this metal oxide reacts with hydrochloric acid, that means that the metal oxide is more reactive than the hydrochloric acid. So, which is more reactive than the hydrogen, zinc or copper? So we can use the reactivity series, which is كنكة مجل carbon zen في BBH كو حجاج أيو. So we have here the zinc and here the copper. So we can see that the copper is less reactive than hydrogen, but the zinc is more reactive than hydrogen. So this metal oxide, of course, is zinc oxide, as this metal oxide reacts with hydrochloric acid and form water and salt. And when it reacts with hydrochloric acid, that means that's more reactive than hydrogen. So which is more reactive than hydrogen, zinc or copper? Of course, it's zinc. So this metal oxide is zinc oxide. Which statement about reactants in redox reaction is correct? Redox reaction means that oxidation and reduction takes place at the same reaction. So an oxidizing agent, it oxidizes another substance and itself is reduced. So it donates electrons? No, I said the oxidizing agent itself is reduced and reduction is gain of electrons. So the oxidizing agent gains electron, does not donate electrons. So that's wrong. When one element gains electron, the oxidation number of the different element increase. When one element gain electrons, so one element is reduced, the oxidation number of different element is increased. So the different element makes oxidation. Yes, that's true. So reduction and oxidation takes place in the same place at the same reaction. So that's true. When one element gains electrons, it's reduced. The oxidation number of different element increased. Yes, the different element is oxidized. Yes, reduction and oxidation takes place at the same reaction. Aluminium is extracted from aluminium oxide by electrolysis. The Onekov equation for the reaction at one of the electrodes is shown, which row describes the change in oxidation number of aluminium and type of reaction at electrode. Of course, we can see that the aluminium gained electrons. It took 3 electrons and became aluminium. The aluminium ion becomes aluminium atom when it gains 3 electrons. So it's gain of electrons, so it's reduction. Change in oxidation number, it increased or decreased? Of course it decreased, as reduction takes place in this reaction, so the oxidation number decreased. Type of reaction, it's reduction, as it's gain of electrons, so it's A. Which statement about dilute hydrochloric acid is correct? Dilute hydrochloric acid, of course, is a strong acid and it's fully dissociated. The weak acids are the carboxylic acids, which are partially dissociated. Which root describes and gives the formula of hydrated copper sulfate? Hydrated, which means that something is chemically combined to water. So description of copper hydrated copper sulfate. It's aqueous? No, it's not aqueous. It's chemically combined to water. So the answer would be C or D. It's chemically combined to water. So of course it's not aqueous. So it will be D, as B is chemically combined to water. Aqueous means that substance just contain waters. It doesn't mean that it's chemically combined to water. So the answer here would be D. The equations for the three reactions are shown. Which reactions are suitable for making precipitation? Precipitation, we put two aqueous salts to react together and it produce one solid and one aqueous salt. So there is two aqueous salts reacting together and it's giving one solid salt and one other aqueous salt. So that's true. Two aqueous salts giving one aqueous salt and one solid salt. So two is true. Three, it's a solid and aqueous reacting together. So that's not true, because precipitation means that two aqueous solutions react together to give one aqueous solution and one solid. So it's one and two. So the answer is A. Acidified potassium manganate dichromate is used to oxidize ethanol. So it's an oxidizing agent. The ionic equation for the reaction is shown. Which properties of transition elements are shown by chromium in this reaction? Does this reaction show that chromium acts as a catalyst? Does this speed the reaction? No, it does not. Doesn't act as a catalyst in this reaction. So it doesn't act as a catalyst. So it's not C or D. It have variable oxidation number. Does this reaction show that it have a variable oxidation number? Yes, because chromium here had a valency of 7 and here it's just has a valency of 3. So that's the variable oxidation state. Its oxidation number was 7 and then it became 3. So this reaction showed that have a variable oxidation number. So the answer is it doesn't act as a catalyst and it have variable oxidation number. So the answer is C. Which statements describe the periodic table? The elements are arranged in order of their nuclear number? No, in order of their proton number. So the elements are arranged in order of their proton number. It is used to predict the properties of an element? Yes. So it's 2 and 3. So it's C. Which row shows the correct order of reactivity of the four named metals? We can know the order of reactivity using the reactivity series, which is Kanaka, Magal, Carbon, Zen, Phi, BBH, Ku, Haggag, Ayu. So, which is the most reactive, magnesium or silver? Silver is here and magnesium is here. So, of course, the more reactive is magnesium. So, it's not C or D. After magnesium, what comes? Copper or zinc? Which is more reactive, copper or zinc? So we can see that zinc is here and copper is below zinc. So zinc is more reactive. So the answer is B. Four iron nails are added to four different metal sulfate solution. In which solution does the displacement reaction occur? So we need to find a metal which is less reactive than iron. So iron can displace it and make displacement reaction. So which metal from those four is less reactive than iron? So we can look at the activity series. Here is the iron. Is copper less reactive than iron? Yes, it's below iron. Copper is here, so it's copper. Is magnesium less reactive than copper? No, magnesium is above copper, is above iron, so it's not less reactive than iron. So iron cannot displace magnesium, so it's not magnesium sulfate. Sodium. Sodium is at the top of the reactivity series, so of course it's more reactive than iron, and the iron cannot displace it, so it's not sodium. Is it zinc? No, zinc is above iron, so it's more reactive than iron, so iron cannot displace it. So the only one heat that's this reactive than iron, so iron can displace it, is copper. So the solution that can make a displacement reaction with iron nails is copper sulfate, as iron is more active than copper, so it can displace copper. A fertilizer contains ammonium nitrate and potassium phosphate. Why is the fertilizer described as NPK? N, which is nitrates, P phosphorus, K potassium. So we need to choose the answer that fertilizer contain nitrates and phosphorus and potassium. So it's D. It provides the three main elements needed for improved plant growth. Yes, it contains the three main elements. That's what's NPK means. What are the approximate percentages of oxygen and nitrogen in clean dry air? Percentage of oxygen, of course, 21 and nitrogen 78, so it's B. Which compounds have similar chemical properties? Of course, the compounds in the same homologous series are having the same chemical properties. So we need to choose two compounds which are in the same homologous series. So butanol and butanoic acid. No, butanol is alcohol and butanoic acid is carboxylic acid. So they are not in the same homologous series. So they does not have a same chemical properties. Ethane and ethene. No, ethane is alkane and ethene is alkenes. They are from different homologous series. So that's wrong. Methane and butane, they're both alkanes, so they are in the same homologous series, so they have the same chemical properties. So yes, that's true. Propene and propanol. Propene is alkene, propanol is alcohol, so they're not in the same homologous series. So that's wrong. So the answer is C. Four statements about organic compounds are listed. B is saturated hydrocarbon. Saturated hydrocarbon, which means it's an alkane. The formula of Q is CH3CH3, so which means that its molecular formula is CH9. so it's alkane. Why? As it displays its general formula, which is C2H2N plus 2. It's C2H6. So it display the general formula of the alkane, which is CnH2n plus 2, as it's C2H6, as it's CH3 and CH3, so it's C2H6, so it's an alkane, as it displays its general formula, which is C2NH2n plus 2. Molecule R contains only one oxygen. It's an alcohol, because the alcohol functional group is OH, so it contains one oxygen. Compound S is the carboxylic acid, so it contains COH group. Okay, which statements about these compounds is correct? P and Q are members of different homologous series. P is alkane and Q is alkane. So that's wrong. They are members of the same homologous series. P and S are members of the same homologous series. P is alkane, S is carboxylic acid. So that's wrong. Q and S. Q is alkane, S is carboxylic acid. Are members of the same homologous series? No, that's wrong. Are members of different homologous series. Q or S are all members of different homologous series. Q is alkane, S is carboxylic acid, R is alcohol. So they are all members of different homologous series. So the answer is D. The structure of an organic compound is shown. What is the name of the compound? It contains two carbons, so of course it's F. It contains chlorine, so it's chloro F. As contain one chlorine, it's chloro F. And it's saturated, it's all single bonds, so it's chloroethane. So it's a chloroethane. Which statement about the manufacture of ethene from large alkanes molecule is correct? Of course, ethene is produced from large alkanes molecules by cracking. So cracking needs high temperature and high pressure and some catalyst. A low temperature is required? No. The process is called cracking? Yes, that's true. The process requires an excess oxygen? No. Water is also a product? No. The products are short chain alkanes and an alkene. So there is no water as a product. So it's B. The process is called cracking. Yes. Which processes are used to make ethanoic acid? Ethanoic acid, which have a COH group. Heating ethanol have OH group with acidified potassium manganate. That's an oxidizing agent. So it's oxidized ethanol when it reacts with it. So when it oxidizes ethanol, it give it another oxygen. So ethanol can be an acid, as an acid have one extra oxygen than ethanol. So that's true. That would produce acid. Bacterial oxidation of ethanol. When I oxidize ethanol, I give it more oxygen. So it can be ethanoic acid because ethanoic acid has one more oxygen than ethanol. So yes, that's true too. Distilling ethanol using fractional column. Of course, that's wrong. Ethanol to become an acid, it need to take oxygen. So when I make for it distillation, it doesn't take oxygen, so it doesn't form carboxylic acid. So that's wrong. So it's 1 and 2. So it's the answer is A. Which statement about propene is correct? Propene is an alkene. It undergoes addition reaction. Propene reacts with bromine in Doric in a substitution reaction? No, that's wrong. Propene is an alkene, and alkenes just make addition reaction. Alkanes make substitution, but alkenes make addition. So A is wrong. Propene reacts with steam in the presence of alkaline catalyst forming alcohol. Catalytic addition of steam. Is the catalyst in the catalytic addition of steam is alkaline catalyst? No, it's phosphoric acid. So it's acid, not alkaline catalyst. So it's wrong. Propene undergoes addition polymerization. Yes, it undergoes addition polymerization. Forming polyethene? No, propene will form polypropene. So C is wrong too. D. Propene undergoes an addition reaction to form alkane. Yes, that's true. When alkenes undergoes addition reaction, it forms alkanes because it's called hydrogenation. It's addition of hydrogen. So it becomes saturated and become alkane. How many of each type of bond are present in ethanoic acid? So we would draw this. So it's so CH3, so CH3, so that's C and three H's. Then C, so C double O. It's a carboxylic acid, so it will have the COH group. So it's drawn C double bond O and C bond OH, as it's a carboxylic acid, as it have the COH group. So how many CH bonds? One, two, three, three. So it's A or B, it's not C or D. How many C to C bonds? It's only one bond. So it's not B, it's A. And how many C double bond O bond? It's only one, so it's A. Which diagram represents the structure of a protein? We need a structure that contains an amide bond. So this contains an amide bond. We can see the amide bond. But the nitrogen is facing another nitrogen and the carbon is facing another carbon. So when the atoms face each other, that's nylon, not protein. So it's not A. B, it's a polyester. It contains an ester bond. So B is wrong. C, it's starch. So it's wrong. D, it contains amide bond and the atoms are facing opposite atoms. It's not facing each other. The nitrogen faces carbon and here also the nitrogen faces carbon, so it's not nylon, it's protein. So it's nylon when the atoms faces each other, when the nitrogen faces the nitrogen and carbon faces the nitrogen, and carbon faces the carbon. But it's nitrogen when it's opposite, when the atoms doesn't face each other. Here, nitrogen faces carbon, it doesn't face itself. So here it's protein, not nylon. So D is the protein. How is the RF value of the substance S can be calculated? The RF value is the is the distance moved by the substance divide distance moved by the solvent. So where is the distance moved by the substance? That's the substance and that's the distance moved by it. So it's Y divide the distance moved by the solvent. Where is the distance moved by the solvent? It's X. That's the distance moved by the solvent. So Y divide X. So it's C. We calculate the distance from the baseline. So W is wrong and Z is wrong. Some information about solid silver chloride and solid sodium chloride is shown. Silver chloride and sodium chloride does not dissolve in kerosene. Okay. Silver chloride is insoluble in water, but sodium chloride is soluble in water. Okay. The boiling point of silver chloride is 1547 and the boiling point of sodium chloride is 1413. Which processes are used to separate a mixture of solid silver chloride and solid sodium chloride? Add kerosene? No, it cannot separate them because both are insoluble in kerosene. So kerosene is wrong. Add water, stir and filter? Yes. When I add water, the sodium chloride dissolves in water. So when I add water, then I stir and then I filter. As the sodium chloride is soluble in water, so it will be the filtrate, and as the silver chloride is insoluble in water, it will be the residue. So I can separate them. So it's B. Which statement describes how a flame test is done? Tip of a clean wire is dipped into substance and the wire is placed in the blue Bunsen burner. Yes, that's true. Tip of a clean wire is dipped in substance and the wire is placed in zero Bunsen burner. No, we don't use the red Bunsen burner because it covers the color of the metal. It covers the color of the flame of the metal, so I can see the color clearly. And also, it's not hot enough, so it's not yellow Bunsen burner. And we does not use a wooden splint. We use a clean wire. So the answer is A. So that's all for today.